Okay, so far we looked at what a relation is, and we were relating two sets of data, and we have inputs relating to the outputs, and that's what makes a relation. And we looked at 4 different ways we can show a relation. We had the mapping diagram as a table of values, graphing, and with x and y coordinates, like as a point. Now we want to look at the definition of what a function is. And a function here is a specific relation where each element of the domain, so that's the x's, corresponds with exactly one element in the range. So the domain can only go to one number in the range. So let's look at problem 3 in your notes packets. We have an A and a B here. It's not written in your notes packets, but let's look at A in the video here. Here we have a mapping diagram. We want to decide if this relation is a function. Notice we have our domain numbers. We can only have the domain going to one range number. So right now, -3 only goes to -2, so that's good. 0 only goes to 7, that's good. 4 only goes to 1, that's good. So that means this relation is a function. For it to be not a function, you would see 2 arrows going off of one domain number like that. But this one didn't have that, so yes, it is a relation. Let's look at example B. For example B, we are seeing a list of points. So again, the x can only go to one y. So here I have 4 going to -1, 8 going to 6, 1 going to -1, 6 going to 6. Uh-oh, I have 4 going to +1, but I already had 4 going to -1. So this is not a function. So what you're really looking for is x's can't repeat. It's not allowed to see the x's repeat. So it's kind of like a little shortcut. Make sure none of your x's repeat. And that would mean the relation is a function if they do not repeat. Let's move on to problem 4. So we decided if a relation was a function in example 3. We looked at a mapping diagram and a list of points. We can now look at a graph and use what we call a vertical line test. For a vertical line test, what you can actually do is hold your pencil on your paper vertically, that's up and down, and slide it across a graph. So here in our example, we slide it across a graph, and notice my pencil or my vertical line crosses the graph at 2 points. That means this is not a function. So you want to drag your pencil across the graph. If it crosses more than once at one moment, then the graph is not a function. So let's look at example 4. So in problem 4a, you can see a very similar graph to what we just saw, and if I put my pencil where this red dotted line is, my pencil will cross the graph at 2 locations. That means this is not a function. Let's look at B. They put my pencil where this red dotted line is and only crosses one time. I can continue dragging my pencil across. Let's say right here, it only crosses one time. What if I drag it here? It only crosses one time. No matter where I draw my vertical line, it will only cross one time, so that means yes, this is a function. Let's look at C. If I draw my vertical line through this first point, it only crosses here, vertically through here. At any one point, it's one time. Uh-oh, what happens when I draw my vertical line here? There's a point at the top here and a point here. So that means it crosses 2 times at this vertical line, so this 2 will not be a function. Right here in your notes packet, why don't you try drawing another yes function? Here could be an example. What did you draw? Please list any questions you still have about this video. Thank you.